If you want to understand how to solve dilution and evaporation problems, this video is for you, because in this video I will make this topic very easy for you to understand. I'll start off with the equation that we will be using. M1 times V1 is equal to M2 times V2. Now what exactly does this mean? Well, M is going to be our concentration, or molarity, same thing, and our V is just going to be our volume. 1 and 2 are going to be initial and final respectively. In other words, we can say that the initial concentration times the initial volume should be the same as the final concentration times the final volume. Now let's do some practice problems to solidify this concept. Before we get into the practice problems for this video, I just want to lay out some terms. The first is dilution. When you have dilution, your volume is going to rise, and your concentration is going to decrease. The next term is evaporation, and this is going to be the opposite of a dilution. In evaporation, you're going to lose volume, so you're going to go down, and your concentration is going to rise. What is the final volume of a 2.41 m solution that resulted from diluting 15 milliliters of a 3.0 m solution? We are told that we want to find final volume. Let's write out the equation we will be using. M1 times V1 equals M2 times V2. Our task is to find the final volume, which is V2. And so we know that all the other variables are given. So now we just need to correctly assign them. Reading this question, this is what was diluted. So this should be the initial, what we started with. So what we started with was a 3 molar solution. We're going to multiply that by the initial volume of 15 ml. And that is equal to the final concentration, which is 2.41 m, times the final volume. Final volume we still need to find, so we'll just keep that as V2. Now in order to solve for V2, all that means is have V2 on one side and have all the other numbers on the other side. And so if we want V2 on one side, we're going to divide by the number that we want to get rid of, 2.41 m. And if we do the division on one side, we need to also do it on the other side. Now according to the properties of fractions, I know that if I have the same number on the top and on the bottom, that's going to cancel out and just become the number 1. And so now we have V2 times 1 on one side, which is essentially just V2. So you can imagine that these things can go away, and we're left with V2 on one side. And so we know that V2 is equal to the left side. The left side, as you can see, we have the unit of molarity on the top and bottom. These units cancel out, which will leave us with the unit of milliliters. And when you do this calculation of 3 times 15, all divided by 2.41, you're going to end up with 18.67 ml. And this is going to be equal to V2, your final volume. Just to make sure this makes sense, our initial volume is smaller than our final volume, which makes sense because we diluted this solution. We added some water into it to dilute it. Find the initial concentration if 22.04 milliliters of solution was diluted to 0.055 liters of 3.8 m concentration. Let's have our equation here. M1 times V1 is equal to M2 times V2. Now all we need to do is plug in the numbers. So let's see here. We have find the initial concentration. We have this one missing. So this one is the one we want to find, the initial concentration, M1. And so we are given all the others. Now if you're paying attention, you will see that there is a conflict between the units. This volume is given in liters, and this volume is given in ml. And so what we need to do is make sure that they're both in L or both in ml, both in milliliters or both in liters. I'll choose to make both of them in milliliters. And so that means I'm going to have to convert 0.055 liters to ml. Now the easy trick for this is just to move the decimal point 3 places to the right so we can find the number of milliliters. So if we do that, we have 1, 2, 3 places, and so that means we have 55 milliliters. Right, so I will replace this number with the number we found in milliliters, which is 55. Now let's start plugging in the numbers to solve this question. We're trying to find M1, which I will write as its variable form, and then we're going to plug in values for the values that we know. So V1 is going to be 22.04, and that unit will be in ml. And so how do we know that? Well, we know that this information at the bottom, the 55 ml and the 3.8 concentration, those are going to be the values for afterwards, so the final values. So the only volume left is going to have to be our initial volume. Moving on with our equation, we see that the left side will equal the next side. So the next side has a concentration of 3.8 for the M2, and it's going to have 55 ml as its final volume. To find the initial concentration, I need M1 by itself on the left side. So I will divide by 22.04 ml on both sides. And this is so that this number cancels out on the left. Next, I know that if I have ml on the top over here and ml at the bottom, these also cancel out, which should leave me with a unit of molarity. The initial concentration should be 9.48, and that's going to be in a unit of molarity for your concentration. So make sure that when you're doing dilution and evaporation problems, you pay attention to what units you're given, so that when you do your math, the unit is going to be correct. Find the final molarity of 70 milliliters of solution. It began with 84.26 milliliters of a 1.077 times 10 to the negative 3 m solution. Is this dilution or evaporation? Let's write our equation that we want to use. m1 times v1 equals m2 times v2. Given the question, we need to find the final molarity, so that means find the final concentration, m2. This part right here tells us what we began with, so our initial values, and so the only volume left up here must be the final volume. So let's plug these numbers in. So we're looking at the initial concentration of 1.077 times 10 to the negative 3 m. We will multiply this by the initial volume, m1 of 84.26 ml. That's the unit for volume. And we'll set this equal to the right side. On the right side, we have the one we want to find, m2, and our final volume is going to be 70 ml. In order to solve for m2, let's divide both sides by 70 ml. On the right side, 70 milliliters over 70 milliliters, this is going to go away and just become 1. On the left side, we see that ml on the top and the bottom is going to also cancel out, leaving us with m, or molarity. 1.077 times 10 to the negative 3 times 84.26 all divided by 70 will give you the value of 1.296 times 10 to the negative 3 m, or molarity. And so this is going to be the value for your final concentration. Now this question had two parts. It wanted to know whether this was a dilution or an evaporation. Now there are two ways to identify whether something was diluted or evaporated. One way is by comparing the concentrations, and the other way is by comparing the volumes. In the case of the concentrations, if the final concentration is more than the initial concentration, then you have an evaporation. And if it's the opposite case, then you have a dilution. Now in the case of volumes, if your final volume is more than your initial volume, then that means you had a dilution. And if it's the other way around, then you had an evaporation. To make it easier on ourselves, let's compare the volumes. V1 was equal to 84.26 ml. On the other hand, V2 was equal to 70 ml. Remember, 1 is initial, or what you start with, and 2 means afterwards, or final. So we went from 84.26 to 70. And so as you can see, this is going to be a decrease, means we had an evaporation. Now that is the end of this video. There's a link down below for science and math tutoring, my website, my publications, my supplies, and books I'm reading. If you're looking for more videos to watch, I have one here about finding molar mass, and one here which is my newest video. Thank you so much for watching, and I will see you next time.